This is our next panel, okay, about engineering design challenges, okay, and then we'll have five presentations during this time.
So, hi guys. Can I start now? Yeah.
Yes.
So, yeah, hi guys. I'm here to present about 3D printing for Martian habitats and other engineering structures using regolith soil. So, introducing about myself, I'm Girinath, and I'm studying Bachelor's of Mechatronics in Kaunas University, Lithuania. So, I would like to thank Professor Julio before going further into this project for giving me this great opportunity and talking about this concept. So what's my main concept of this project is the main goal of the project is to create a 3D printing method for construction of Martian engineering structures using regolith soil present in the Martian environment. So we are using a robotic arm for the printing construction using a suitable conditions for regolith to make it more hard and perfect structure. So what's the need of the project is in modern days the space race has been growing rapidly across different countries, which include the Martian mission as well. So as there is going to be a lot of crewed missions uh, the, within next 15 to 20 years, so there comes a bigger need for the construction of habitats for the astronauts to stay with the amount of weight carried, which will be more limited due to the launch factors. So there comes a need for creating an habitat. You use like the habitat for habitat in Mars using the insight to resource utilization. So it will be playing a major role to reduce the risk and the expenses for the future missions. So why do we need to use regolith? Regolith is nothing but a layer of soil on constellated rock found in Mars and lunar surfaces and in few other asteroids. So regolith is an abundant resource. Regolith is found in Earth, even in the alluvium soil as well. You can find a lot of alluvium soil in India and Brazil as well, which is very less when compared to Lithuania. We don't have much alluvium soil. So regolith is found like it's formed by uh, various biological and weathering factors. These regolith is formed by bedrocks broken down into small due to weathering conditions. And the regolith found in the surface of Mars was found by the Martian soil. It is toxic. It contains perchlorate compounds, which is mostly chlorine. This data was confirmed by several rover systems, uh, by the Martian rovers such as Curiosity, Opportunity, Spirit. This Martian rovers are confirmed it by using gas chromatography, laser, and mass spectroscopy methods to determine this. So it is like the structure is designed by using the PLA basalt fiber, which can be also used as a used as another other aggregate material processed in Mars. So the basic materials needed for the project are for project process is aggregate water and cement, which I was talking earlier. So the aggregate mentioned here is the regolith, which can be obtained in Martian soil. The water can be obtained from Mars itself, combining hydrogen oxygen present in the Martian atmosphere, or it can be supplied by the surface of Mars. And calcium oxide can be found in the surface of Mars as well. The construction of the material regolith can be made stronger by using epoxy resin and tetraethylene due to its property. like properties of strength, resistance, and flexibility. These components can be used artificially, like uh, artificially created in the by the Martian soil in Earth. They already made a test for this kind of components. This preliminary test have produced like produced some results for mechanical tightness, thermal stability, and water resistance. This polymer can be added in the mixture along with aggregate water and cement. So the construction can be two ways. Two ways, either can be controlled by the ground station, or otherwise controlled by the crewmates who are involved in the mission. It can be controlled from the Earth, or like it can be controlled in the Mars as well. Uh, the process from ground station, we can use can be engineer who's good at programming in 3D printer and control systems involved in a robotic arm. And the process of controlling robots from the ground station can be like made possible by deploying a rover with a robotic arm uh, to construction site. But there is a slight disadvantage of time delays when it comes to the construction from the ground station. So I'm just trying to show you guys a small video about the regolith structures. Yeah. This structure is more sustainable as well when it comes to the construction. So so it's like it's more flexible and more possible in engineering terms. So this video demonstrates the possibilities of the construction. You can see a robotic arm just revolving around for the construction of the structure which we need. So I'll just stop the video and going to the next slide. So the robotic device which I was saying earlier, to begin the construction of the structure, the mixed paste is needed to be injected in the valve of robotic device. Then it should be programmed with proper pumping setting for the structure. The robotic arm which we are going to use will be having 6 degrees of freedom on the XYZ positive and negative directions. X is a 4, and the aft, the distance from away from the base. Y is the upwards and the downwards direction. The height of the robot can be adjusted in the Y directions. The distance away from the ground will be also comes under the Y. So the Z is for the sideways motion of the robotic arm. So the workflow of the robotic printer you start the robot, and like you give a task for input task for the robot, for the operating station of the robot, like which it will be either present in the ground station, or it will be present on the Mars itself, which will be like controlled by the engineers present in the Mars, like few analog astronauts who are good at that technology can be doing this work, and the data will be stored in the machine. They just need to monitor the heating process and the injection stats. Then it brings a layer, and if it wants to, like, when the process is complete after finishing a layer, it just goes to the end. If it's not the end, it just restarts again. It collects the data, it does the process again, the process gets repeating, and until the end of the process, it's going to be a loop, which is going to be like more interesting. And from the conclusion of this project, 3D printing is an automated process which will be always possible operation. Thus, in the end, it comes to the skilled crewmate or the operator from the ground who can program it and monitor the process. Still, 3D printing has a few flaws, but I guess we guys can correct the flaws which we have, and try to work on more accurate 3D printing devices. The robotic arm can be used to pump the mixture on the focused work area. The structures can be created by it are like they're airtight and the products out the environment. Still, the crew can work on few more layers of inner shell for more safer workspace if they're concerned about the air leakage or something. So this device can be more sustainable. It can be broken into parts, and it can be used for other bigger processes in the work, like workstation itself. So that's it for my project, and these are my references. Thank you.